So for this, we want to find the z-score that corresponds to the percentiles P5, P50, and P90. So for one, you just have to understand again that what we're doing here isn't actually different so much as it's a different framing. We're still looking for cumulative areas, except that when we say P5, it means we want the breakoff for the amount of data that has 5% below it, so a cumulative area of 0.05. In that first case, if we want to find what breaks off that region, well, we'd have a picture like this, ignoring that bit at the bottom that tells us what our answer is, which we can find using that inverse normal function, again, in the calculator, or if you prefer working with the table, you can use the table, but you have I and V norm 0.0501, which is approximately equal to negative 1.645. Then, in that second case, we'd have a diagram looking something like this, where if we want to find that area, it's the same idea actually, we still just use that value. We can still just work in terms of the inverse normal function, where now we're looking at 1/2, 0, 1, but truthfully we shouldn't have to check this, because if we want 50% to the left, that means we want the mean, because the mean's always in the middle. It's always going to have 50% to its left and 50% to its right. So you should be able to tell, without doing any math, that the answer here is 0, because we're talking about standard normal. But just to be sure, we can do that in the calculator. And then for our third case, we want to find the value that has 90% of data to its left. Still nothing special. Inverse norm 0.901. In this case, will be approximately 1.28. And I'll say that this value, 1.28, is an important one to know. As we're moving to Chapter 6 and Chapter 7, it's a value we're going to see a lot for reasons that will make more sense in those contexts, but just bear in mind that I'm not going to ask you to memorize too many z-scores. This is one that is good to have bouncing around in your head, though. And next, we're going to talk about how we can do these things not just for the standard normal distribution, because standard normal is not very common, but we're going to see how we can do this stuff for more general normal distributions. That is, how we can compute x values given things like areas or percentiles.